Hi everyone, here is the lesson of topic 3. So I would like to make the lesson, just lesson number 3 for you here. Before I start, okay, let me just choose my pen. Okay, so here this is logarithm, about logarithm. Logarithm is inverse of exponential function, which you saw in topic 2. So before I start, I would like to talk about a function and inverse function. Actually, you can do the lesson and do several questions and then do your quiz and do your tests and then pass the course. But I really like you to I really like to try my best to make you to remember, to learn instead of just memorizing. So in order to do that, I have to make some connections between two lessons. I have to give you some maybe just some pre-information, for example. And then you say, oh, okay, so this is the connection between two lessons. That's the reason I need to know this lesson. That's the result of the lesson. This is the application of the lesson. And then you learn and you don't memorize. Okay? Logarithm is, as I said, logarithm is, okay, so here if it's really working. Okay, so logarithm is inverse of exponential function. But then you ask, what is inverse function? Inverse function doesn't mean 1 over. No, here doesn't mean that. Okay, I show you what do I mean. Okay, y, for example, equal x cube. Okay, so what do I have for x and y? Okay, if I give you x, you give me 1. Okay, as y, because it's 1 cubed. Okay, 1 cubed, that's 1. If I give you 2, you see, okay, that's here 2 cubed, which is 8. If I give you 3, then you say, okay, that's 3 cubed, which is 27. Then I say, okay, how about cube root? Oh, it seems there is connection between them because one of them cube root. Okay, so x and y. If I give you 1, it gives me 1 because it's cube root of 1, so that's 1. If I give you 8, it's cube root of 8, which is 2. If I give you 27, it is cube root of 27, and that's 3. Okay? So, as you can see, x here is y here, and y here is x here. That's great. Okay, that's great to see. Oh, okay, x and y, they exchange. X of 1 is y of the other, and y of 1 is x of the other. They are inverse of each other. Okay, maybe now you can think of several inverse functions on your own. Another way, for example, I like to show you this way. Some symbol of inverse function is f power minus 1x, but it doesn't mean 1 over fx. No. See, I have y equal, so for example, I can say I have fx is fx x cubed, and I have f power minus 1, or no, I don't say f power minus 1. That's inverse function. So don't say f power minus 1. Okay, so I want to say the mistake to tell you don't make that mistake. That's inverse function. Inverse function is shown this way with this symbol. This is cube root of x. But this is not 1 over fx. No, it's not. It's not 1 over fx. It's not like f power minus 1. No, I just show it this way. That's a symbol, like my name. Okay, so again, the lesson is logarithm. Logarithm of inverse of exponential function. I can't teach you logarithm and go on and go on. You learn, you do some questions, you pass your quiz and tests, and you go, but then you forget. But when I tell you, okay, this is the connection between this lesson and the previous lesson, then you remember much better. I try my best. Okay? So I say logarithm, which I'm going to teach you now, is inverse of exponential function. Then you ask, what is inverse function? I show you inverse function. Okay, inverse function like x cube and cube root. So x of 1 is y of the other. Y of 1 is x of the other. How do I show inverse function? F power minus 1. But this is just, I'm showing it. doesn't mean f power minus 1, which is 1 over fx. No, that's a symbol. A symbol for inverse function is that, like my name. Okay, look at this. Here you don't know the function. I didn't tell you it's x cubed. No, I didn't tell you. But I just tell you 2 goes to 9, 4 goes to 5, 11 goes to 6. What do you expect for the inverse? For the inverse, you expect 9 goes to 2, 5 goes to 4, 6 goes to 11. Okay? See, this one here, which is x, is y here. And this one here, which is y, is x here. Okay? Perfect. So now, what is the relationship between graph of a function and graph of inverse function? Graph of a function and graph of inverse function, they are, okay, so just 1 second. Okay, they are reflected of each other towards this line. What do I mean here? See, if I find this point, for example, this point is, for example, A and B. Okay, so this point is A and B. What is the relationship? Okay, so B is A cubed, for example. Okay, so now I make a perpendicular line here and I continue here. Okay, I continue here and I find this point. This point for sure is B and A because X and Y, they exchange. Okay, B and A. And here A is cube root of B. Okay, so just 1 second here. Oh, yeah. Okay, so A is cube root of B here. Okay, they are just reflected towards this line. Which line? Y equal X, which is the green line. Oh, perfect. So now I know logarithm, which is the lesson, is inverse of exponential. Now I know meaning of inverse function. X and Y, they exchange. X of one is Y of the other. Y of one is the X of the other. Now I know what is the symbol, and now I know what is the relationship between the function and its graph. Okay, so just 1 second. Yeah. Okay, so a function and its inverse. So example of that, yes, example of that is here. So I did it, okay? So now I continue. Okay, now I want to talk about logarithm. As I said, logarithm is inverse of exponential. I like to refresh your mind for exponential. Okay, exponential function is this, y equal a power x. Remember, x is in the power. Oh, okay. So remember, I told you a must be positive. Yes, I told you in the previous lesson. See, in this case, when I show you with pictures and graphs, and then you don't forget, oh, I forgot, a should be positive or negative. I show you, no, it cannot be negative. A is positive. Okay, so a is less than 1 or a is more than 1. This or this one. Oh, okay. So this is the graph. So these are for a more than 1 and this is for a less than 1. Okay, but all of them a positive. Okay, for sure. That's a graph. Oh, perfect. Yes. Okay, so yes. Okay, so let me just write the function. Okay, so this is do we have it here? Yes. So this one is 1 over 2 power x, and this one is 2 power x, and this one is e power x, and this one is 10 power x. Okay? Yeah. So now I want to do the logarithm. Logarithm and exponential function are inverse of each other. So what does that mean? A very important statement is here. Very, very important statement is here. This one. Okay? So I like to do it in this page and then I continue because there is no room here. Okay. See here. If I learn this, I never forget it. See, logarithm of x base a is y. What does this mean? Means a power y is x, because they are inverse of each other. Oh, okay, it's like a circle. See, you don't forget. Oh, okay, a power y is x. Yes, yes. Okay, so here, x of this is result of this, and y of this, which is result, is input of this. Oh, they are inverse of each other. Okay, okay, okay. So can I have example? Can you give me example? Yes. So see, 2 power 3 is 8. Oh, okay, yes. Logarithm of 8 base 2 is 3. How do I know? Because 2 power 3 is 8. Okay, make this circle and then you never forget. Which one? Which one? I forgot. I don't remember. No, I remember. See, logarithm of a base b is c. Means b power c is a. Okay, then you can remember this way. Oh, okay. So this is the inverse of exponential. Can I say a is positive? Of course, because that's inverse of the other function. Oh, perfect. So when I make connections between two functions, then I don't forget. So I don't really need to tell you that a must be positive. Of course a must be positive, because a was positive for exponential function as well. Okay? A is not 1. Yes, there also a is not 1, because it doesn't make any sense. If I have a equal 1, then I have 1 power x. So 1 power x is just 1. There is no function here. That's just constant number. Okay? So what I know here, that y equal a power x, a is positive, a is not 1, a is more than 1, or a is less than 1. Yes? I have it exactly the same thing here. So logarithm of x power, logarithm of x base a also I should say a must be positive, a is not 1, and a is more than 1, or a is less than 1. The same thing. Okay, the same thing here. Okay, so look at the function here. Okay, so how about the graph? Okay, the graph, I can make the graph of each one by just reflecting towards this line. So I have graph of exponential function, I just use reflection and I find the graph of the other. Okay, I don't want you to make the graph for me. You can just use a for example, app to make the graph, a software, or the graph is here. Okay, or you can make the graph using a table of values. So you give some value to x, you find y, you find those points, and then connect them. Okay, so this way. So not too many details for so the graph. Okay, so now I want to show you several logarithm example here. Okay, several. Okay, so what is 10 power 3? 1000. How can I change this to logarithm? Okay, logarithm of 1000 base 10 is 3, because 10 power 3 is 1000. Oh, perfect. How about, for example, this? Logarithm of 16 base 2. What is the answer? Okay, I just asked you this. You say, okay, 2 power what is 16? 2 power what is 16? Oh, that's 4. Because 2 power 4 is 16. 2 power 4 is 16. Okay? You can make the connection here. So if I have logarithm of x base a y, then I have a power y equal x. So this power this is this one. Okay? So here just I want to show you graph of 2 power x and graph of logarithm x base 2. Okay? Oh, perfect, is here. One of them is this and the other one is this one. See, you can make the reflection and find here. So this one here, this one, the reflection of that is here. Okay? So this point, if this point is A and B, this point is B and A. You just change x and y. Okay? Perfect. Okay, so how about graph of 1 over 2 power x and graph of logarithm x based on half? Okay, the same. I told you it must be reflection towards this line. That's reflection towards this line. Okay, so here, see, 2 power x is y, logarithm of y base 2 is x. Okay, but when I want to show the function, I just do logarithm x base 2 because I want to have input as x and output as y. But when I want to make a connection between these two functions, I say, okay, x and y, they exchange. Okay, so how about here? 1 over 2 power x and logarithm x base, so just base half. Okay, so logarithm x base half, so is y. Okay, it means half 1 over 2 power y is x. Okay, x and y, they exchange, just x of one of them is y of the other one. Oh, perfect. So I know the lesson is logarithm. Right now I know logarithm is inverse of exponential. Then you ask what is inverse. So I show you the inverse function, x and y, they exchange. I show you the inverse function on just input and output. I show you inverse function on graph. Perfect. Oh, perfect. Now what I need to know is when I have logarithm x base a equal y, means a power y is x. This power this is this. Make a circle. You start from bottom, you make a circle and go just to x. Just opposite of clock. Okay? So now let's do these examples. So from here I can say examples start. Okay, so convert each of them to logarithm. Okay, so I just show you this because you need to know it. Okay, y is 8 power x. Logarithm of y base 8 is x. Oh yes, why? Because I have 8 power x y. Logarithm of y base 2 is x plus 1 because 2 power this is this. Logarithm of 4 base a plus 1 is 2x because a plus 1 power 2x is 4. Okay, good. So practice on this formula. How about here? These are very good practice. Okay, so convert logarithm form to exponential form. Oh yes, okay. So logarithm, okay, so I changed the color because it's very just bothering eyes. Okay, so 49 base 7 is y. Means 7 power y is 49. Can I say what is y? Here? Yes, because 7 power y is 7 power 2, which is 49. And y is 2. Yes. Oops, good. Okay, how about this one? Logarithm of x base 4 is 3. Okay, so 4 power 3 is x. So what is x then? X is 64. How about this one? Logarithm of x plus 5 base 2 is y. Oh, okay, so 2 power y is x plus 5. Can I find x? Can I find y? I can't, because I just have one equation, 2 unknown, so I cannot do it. Okay, so here I stop and then I continue in the next video. So this is video number 1. Thank you for your time. I continue after.